Welcome to the second episode of GeoShifters Space News. And today we will start with this. NASA's first lunar landing happened 50 years ago. In 1966, NASA reached a milestone by landing a robotic craft on the lunar surface. The Surveyor 1 was key to helping the Apollo astronauts reach the moon a few years later. The images were collected on tapes and stored away long before computers were commonplace. This means that today there are almost no pictures from this on the internet. But good news! A group at the University of Arizona have digitized more than 93,000 photographs from the Surveyor program. In a few months, these pictures should be available to the public. They already showed us a few of the best pictures. Let's take a look at them. This one looks very scientific. This one is also interesting because it shows some color, and I was thinking that the moon was a black and white planet. Next we continue with a surprise. Surprise, surprise, surprise. The universe is expanding faster than scientists thought. To be more precise, 5 to 9% faster. This surprising finding may be an important clue to understanding those mysterious parts of the universe that make up 95% of everything and don't emit light, such as dark energy, dark matter, and dark radiation. This amazingly important and interesting study was done by Adam Rees, an astrophysicist at the Space Telescope Science Institute, who won the Nobel Prize in 2011 for the discovery that the universe expansion is accelerating. And all of this crap all comes from the data from the Hubble telescope, which makes it all nonsense. Next we need to learn about hairdryers in space because they use a lot of electricity and it's important that we have hairdryers if we do a mission to Mars. So for that we have a special guest that will explain us about it.
I'm a little spacecraft. Sorry. These three solar arrays take light and convert it directly into electricity. This little motor is powered by a solar panel also. When we turn it toward the light, the motor starts to run. The light driving this panel passes through a rectangle this big. But as we move farther from the source of light, there'll be less and less electricity to drive the motor. If we're twice as far away, that same amount of light is now spread out over 4 rectangles. So the motor only has a quarter as much energy to run it. If we go out 3 times as far away, that same amount of light is now spread out over an area 3 by 3. So the motor only has 1/9 as much energy to drive it. At 4 times as far away, that same amount of light is spread out over an area 4 by 4. The motor's only getting 1/16 as much energy, so it's barely turning. Now, in the case of the Juno spacecraft, if it's in orbit around the Earth, it has 12,000 watts of electricity. That's enough to run this whole studio. But by the time it gets way out in orbit around Jupiter, these same solar arrays are only going to be able to produce 400 watts. If you had a hairdryer like this, it would run fine when it's near the sun. But as we moved out farther and farther from the sun, the hairdryer would have less and less energy available to it. In fact, a typical hairdryer powered by the Juno spacecraft out at Jupiter wouldn't have enough energy to run at all. But because the instruments on board Juno are so efficient, it's going to work just fine. Of course, you might wonder why you would take a hairdryer out to Jupiter to dry your hair. Well, you wouldn't. I mean, it's just to give you an idea of the power.